slopes of Mount Hood, top of Mount Hood is about 11,000 feet, which puts it over 2 miles high. At the peak of the last ice age, the ice sheets that covered North America, for example, were over 1 mile higher than Mount Hood and extended at that elevation all the way from the west coast of Canada east to New England.
Scientists believe that at the start of the Ice Age, several different glaciers form in the mountains of northern Canada. After thousands of years, these great walls of ice merge and advance as one. Scientists call it the Laurentide Ice Sheet, named for the Laurentian mountains that it engulfs. A glacier like the Laurentide Ice Sheet is supercompacted snow. As the snow accumulates, it becomes denser and denser until it becomes ice. If the summers are cool, then the ice does not melt. As more and more snow accumulates, glaciers like the Laurentide Ice Sheet begin to move under their own weight.
The southern margin of this large ice sheet started to advance southwards towards the U.S. And initially the margin was a pretty continuous, sort of long curved margin that was advancing slowly downwards. But then once it got into the Great Lakes region, the ice started to advance in the Great Lakes as these lobes of ice.
Each lobe of ice travels at different speeds, depending on local weather and conditions on the surface. This is how far the Laurentide Ice Sheet advances. Soon, however, the Earth begins to warm and the glaciers begin to recede. During this warming period, humans and megafauna take advantage of a flourishing ecosystem. But around 10,000 BC, the global climate abruptly reverses, and human survival is suddenly placed in jeopardy. To discover why this abrupt change happened, Dr. Ed Brooke examines ice cores.
An ice core is a cylinder of ice that we collect by boring through the polar ice sheets with a specialized drilling tool. We get back this really pristine looking cylinder of ice that's up to about 2 miles long, and we can learn all kinds of things by measuring the chemical composition of the ice.
Dr. Brooke has dug ice cores on glaciers in Greenland and Antarctica. To understand the climate prehistoric humans must endure around 10,000 BC, Dr. Brooke studies both the ice itself and the air trapped within it.
Ice is definitely not just frozen water. There are little air pockets in the polar ice, little bubbles in them, containing ancient atmospheres. There's not very much air, but there's enough to make good measurements of many of the things we're interested in.
One of which is the greenhouse gas methane. In the northern hemisphere, swamps and bogs naturally produce methane gases. The wetter and warmer the climate is, the more methane is produced. In order to examine the air that Paleo-Indians and mammoths breathed, Dr. Brooke cuts several slices of 13,000-year-old ice and melts it under controlled conditions.
When we want to analyze the sample, we get the pieces we want, cut them to the right shapes, take them into the lab, where we will then carefully place the samples in vacuum containers that we can seal them in and then pump away the air from the lab. So we're just left with ice with bubbles.
The vacuum-sealed containers with ice are lowered into a warm bath. As the ice melts, the air bubbles rise and are extracted.
At that point, the challenge is to get the air out of the bubbles without contaminating the sample.
The last time these air bubbles floated freely, Paleo-Indians flint-knapped Cloves projectile points, and mammoths roamed the Earth. These tiny crystal balls into the past allow scientists to peer into the Earth's climatic history. The amount of methane in the ice is revealing.
Can I look at yesterday's data? Sure. What we see methane doing in these ice core records is varying very, very abruptly. When we see methane change, we are fairly sure that what we're seeing is a fairly widespread climate change throughout the world.
A climate change that is fast and furious. After hundreds of years of warming, reduced methane levels, among other factors, tell scientists the Earth very suddenly and very quickly cools and returns to Ice Age conditions. Scientists call it the Younger Dryas, named for an Arctic flower that flourished during the time period.
There was a sudden reversal of geological fortune, as it were. The world suddenly stopped getting warmer, and for a very brief moment in geological time, about 1,000 years, ice re-advanced, glacial conditions came back, and in many ways it was a surprise to plants, animals, and probably people as well.
The climate in the northern hemisphere becomes dry and cold. In some areas, winter winds kick up dry, loose sediment, ravaging the landscape with massive dust storms, leaving it completely uninhabitable. Now is the time for prehistoric humans and all species on the planet to adapt or die.
Are we